Hello, can you hear me?
Yes.
Okay. Yep. Okay. Can I start? Yes. Yeah, I'm gonna start. Okay. So I'm Jesse, working at an edtech company based in Tokyo. So my Twitter account is Jesse Tetsuya. I'm gonna upload my slides on Twitter. So if you have some interest in, you can follow me. If you have some questions or comments when I'm presenting, please comment in the chat space of Zoom. So if we could have enough time, I'm going to answer them after this talk is finished. So I mostly work in both data science and engineering and have been involved with several AI ML projects and have been implementing ML APIs and ML ops environment. So based on my experience, I'm gonna try to how I transform research-oriented code into machine learning APIs with Python. So the reason I'm going to talk about these topics is because recently Python engineers have more opportunities to work with data scientists and researchers than before. So understanding the process to develop ML APIs can help make AI ML projects work more smoothly. So the target audience might be engineers who are working with data scientists or researchers or involved with AI ML projects. So the features of data might be different based on each industry. So before starting to explain the main topic, please quickly let me share domain knowledge about EdTech in order to make my talk more understandable for you. So EdTech means educational technology. One of the major educational technology is learning management system or online learning platform such as Moodle, Blackboard, edX, Coursera, and something like that. So I guess that's some of you are already familiar with them. So these systems have several functions to help learners to study online. For example, online quiz function can be able for students to take online quizzes or online tests, as well as teachers can make online tests and distribute them to students. So video lesson function can make it possible for students to take a lesson from home through a PC screen. So while they are using these functions, the learning log data is stored in database behind the online learning system. So generally, the characteristics of the learning log data has time series format. For example, the data include what students take online tests, what kind of online tests are distributed, when students take online tests, and whether they answer the quizzes or not, and get correct answers or not. So by using the learning log data, a data scientist will write research-oriented code through finding optimal ML models or algorithms. So engineers transform the research-oriented code into ML APIs and integrated them into the LMS or the online learning platform. So this talk focuses on the process of transformation from research-oriented code into ML APIs. So there are 4 steps to transform research-oriented code into ML APIs. So understand the research-oriented code, modularize it, refactor it, and write the code to check how it can behave correctly. So first step is to understand the research-oriented code. So I'm gonna answer these questions. What is research-oriented code? What are ML APIs? How should engineers handle research-oriented code? So I will use Flask in sample code in this talk. So now let's look at definition of research-oriented code. Research-oriented code in AI/ML projects is a code written mainly by data scientists or researchers and for figuring out the most efficient and suitable machine learning model. So machine learning APIs are composed of three elements: preparation code, pre-processing code, and calculation code, which is all machine learning code. Researchers focuses more on writing pre-processing code and ML code through an iterative process, and it is integrated into production code. On the other hand, engineers have more responsibility to write whole part of the code in production level. So this is example of pre-processing code written by researchers. So this code seems to be long function and a use for loop. So this code can allow researchers to visually trace the code from the top to the bottom and easily and quickly write it. So this is a sample ML code with logistic regression. This code uses DotaPen and use data frame, but it can make researchers easily handle input data and trace output data with data frame. This code is example of the code written by engineers. This code seems to be shorter than previous code, and there are list comprehensions and set comprehension. So there are two simple functions on the bottom. So actually, this code can build the model in much faster and simpler way. So I identify three differences between research-oriented code and production code. So there are different scopes, different characteristics of coding style, and different objectives for coding style. So researchers focus more on writing pre-processing code and ML code. On the other hand, engineers have more responsibility to write whole part of the code in production level. So the research-oriented code seems to be easily handled and visually traceable. And on the other hand, production code need to be concerned about high calculation speed, high readability, and then they should be testable and modular. This is because the researchers focuses more on finding the most efficient and suitable machine learning model. And then on the other hand, engineers have more responsibility to make the code work on the server quickly and reliably. So now what are Python engineers supposed to do for research-oriented code? So modularize the research-oriented code into preparation code, pre-processing code, and ML code. And then refactor them, and then write the code to check how it can behave, how it can work correctly. So now second step. Second step is to modularize the code. So there's three small steps. First of all, categorized research-oriented code into preparation code, pre-processing code, and ML code. Secondly, break them out into functions and make them testable. And finally, qualify input and output of the code and define URI. So there is a page of sample research-oriented code written on Jupyter Notebook. This code is written for calculating probabilities to get the students correct answers for certain questions of exam. This code is procedural, and then some of them are not classified. It could be harder for us to understand the role of each code. So I actually wrote it, but I struggled to understand the code. So this is because the research-oriented code seems to be tightly coupled. So in order to categorize this code, find the code to load input data or access database first. It can be categorized as preparation code. Next, find the code to make, replace, filter, or delete input data. It can be pre-processing code. Then find the code to execute calculation or train data. It can be categorized as ML code or calculation code. I could categorize research-oriented code into preparation code, pre-processing code, and ML code like the table on the slide. At the same time, we could get the modules for each from one page of research-oriented code. So preparation.py has functions to access BigQuery, execute query, and load input data and rename columns. Preprocessing.py has functions to replace categorical data with discrete numbers and filter input data. Prediction.py has functions to calculate parameters, logistic regression, and item response theory. So item response theory is also called as two parameters logistic regression. This is used for calculating probabilities to get the student's correct answer. So this statistical method is used mainly in pedagogical domain. So now we can see the research-oriented code became loosely coupled. So now glorify input and output of the whole part of the code and define the URI. So there is a table of input data on the left side on this slide, which is used for two parameters logistic regression. On the left side, there's a table of output data calculated by the model. So the input data is about a student, or whether students answer each question correctly or not. Their item name, which is the name of question, item ID, how difficult each question is, subject names, exam name, and correction, which is binary data. On the other hand, output data is about probabilities to answer questions correctly. The role of the API is to get probabilities so we can directly label probabilities as endpoint name. So based on best practices, function name should be verb or verb plus noun. So the role of this function is to calculate the results or get probabilities so we can label calculate result or get probs as a function name. So understanding what data is input and output, which means understanding what data the code calculates and makes, is considerably important step to make API. So now we could create a skeleton of the ML API modularized from a page of research-oriented code. So now we can move to refactoring phases, but we need to prepare for refactoring first. Then there are two main parts of refactoring, which are IO and pandas code. So let's look at these processes in more detail. But actually, I did not include refactoring of ML code because ML codes tend to be short, and then there might not be spaces to rewrite and fix. So before starting to refactor, we might need to understand more about the code. In order to narrow down requirements of each code, write test code and take notes about the requirements of each code. So there are directories, which I modularized in previous slides. API directory has app.py, which has endpoint to get probabilities, config file, prediction.py, and preparation.py, and preprocessing.py. So test directory has 4 modules of test code for each. So in order to narrow down requirements of each code, I suggest that you write test code and take notes about requirements of each code. So when taking notes in the code, you can use sharp comment out or docstrings. There are 4 kinds of docstring, such as restructured, text style, NumPy style, Google style. So you can choose one that you like. There are only 3 kinds of docstring. I prefer to use Google style because other styles say parameters instead of arguments. So I feel comfortable for using arguments instead of parameters. So after we wrote test code and understood more than 70% or 80% of requirements of each code, so we can start to refactor it. So I'm going to show you a case study with refactoring the code to access BigQuery and GCS by using Google Cloud client libraries with Python. So there are 2 kinds of code on this slide. The code A uses star and extract all of data from dataset and then outputs 2-dimensional arrays. So the code B has a role to extract 3 specific kinds of data from dataset only when column 1 is not null. The query filters values and drop null. So I suggest that you preprocess the data with query as much as possible if you use BigQuery. This is because it is faster and lower cost than preprocessed data with Python. So the cost and processing speed of the BigQuery is increased based on the amount of data processed. So when writing preparation code to access GCS, I suggest that you make bytes object and upload it from memory to GCS with Python. I tended to write the code to make CSV files on local, load it and upload it from local PC to GCS. This is because it allows me to quickly write the code. But as a result, a large amount of CSV files sometimes stay in local PC and consume extra memory of PC. So I suggest that you make bytes object. However, this code on the slide seems to be long, so I should simplify more by developing or using wrapper library. So there are two kinds of code with Google Client libraries which I showed in the previous slides. So it combines and simplifies two kinds of codes. And in so doing, it reduces the total amount of the code. So GCP Accessor is the package I developed. So after this talk is finished, if you have any interest in it, please speak with me. So now we can transform coding style with pandas into coding style with Python only in preprocessing code. So all data in the API should be processed using the same data type. This improves readability and maintainability as opposed to prioritizing processing speed. So one day, I wondered why I struggled so much with refactoring of pre-processing code in research-oriented code that I wrote a previous week. So the reason is that there are many coding styles with pandas, as you can see on the table. For example, filter function has 6 kinds of coding styles. I think that there are more than I wrote here. In case of coding style with Python, it just uses basically list comprehension each function. So pandas is very powerful and useful for data wrangling, but as code might decrease readability depending on situation. So the way of coding without pandas could be easier for engineers to read the code, and it could increase readability and maintainability. So last step is to write the code to check if the code can work correctly. So there are 2 things to do: writing decorators to check parameters, and then setting up production-like environments. This is the image of decorators and APIs. After client send request, APIs check whether parameters are correct or not, and then checks access token. If something wrong with the code happens, error handler will catch the error. So if there's nothing wrong with the code, request will reach to the endpoint. But I don't have enough time to describe all of them, so I'm going to focus on talking about request parameter check. So I'm gonna show an example of request parameter check with JSON schema. So this request card command has student's name and student grade as parameters. This JSON file is sample JSON schema. In this file, you can define what data should be checked and how the data should be checked. So this make name grade.json file is defining the data type of student name as a string, and it must be included as request parameters, and the data type of student grade is also defined as string, and it must be included as true. And the maximum length of characters is limited in 120, and minimum length is 1 character. So in this example, request parameters are not allowed to be empty. So based on the JSON schema, the JSON validate.py validate request parameters. The first validate JSON function checks whether the JSON schema exists or not. The second validate schema function checks whether the request parameters are correct or not based on JSON schema defined in previous slide. So in order to execute these functions, write function name as a syntax sugar under the endpoint. As I looked over JSON validation code on the web, most of the code like this on this slide, so you can easily find a lot of similar sample codes on the web resources. So finally, set up production-like environment with Flask. So these are just tools. So I do not talk about how to use them and tutorials. So I just show you options. So first, set up visualization tools such as Tableau, Google Data Studio, Redash, and Looker. When I try to automate continuous integration, GitHub, Circle CI, and PyTest might be common options. After setting up CI environments, you can deploy on GCP. This might be typical options for ML APIs, as some of you might already know. So also you can monitor the response speed of ML APIs and check the response by implementing system logs and analysis logs in advance. It is useful for engineers to find the drift of model and debug the code. So I suggest that you also look up frameworks based on Flask, such as Flask App Builder, Dash, and Locust. The Flask App Builder allows you to manage and visualize data. Dash can make it possible to interactively communicate with data. The Locust is load test tool, which can also allow you to do scenario test. So there are already a lot of resources about the tools on the web, and tutorials are already presented in the past PyCon around the world. So you can look over them by yourself later. Yeah, I'm gonna share this slide on my Twitter. So if you have any interest in it, you can follow me and look over it later. So now let me quickly summarize the 4 steps to transform research-oriented code into ML APIs. The first step is to understand what research-oriented code in your project looks like, what components of ML APIs are required in your project, and how to handle research-oriented code. Next is to modularize the research-oriented code through 3 small steps. These are to categorize it into preparation code, processing code, and ML code. Then break them out into functions and make them testable. And glorify input and output with the data of the code and define URI. And then thirdly, it is refactoring. So after preparing for refactoring, simplify IO code in preparation code and change coding style with pandas in the Python only code in pre-processing part. So lastly, write the code to check how it can work correctly by implementing decorators and then setting up production-like environment. So that's all. Thank you so much. If you have any interest in it, how I'm refactoring or in the edtech domain or in what our team is doing, feel free to contact with me. Yes, thank you so much. And I'm gonna read some question in chat box. Okay, there is a one question from John. If you deploy ML model on Kubernetes, question is, if you deploy ML model on Kubernetes, you may try seldom. Oh, sorry, this is the question. I think this is this might be your opinion. Oh yes, not sure. services. Okay, I'm gonna look over it later, this link. Thank you so much. Thank you for giving me useful tips. So if you some of you have questions, you can type in the chat space of Zoom, or you can speak out. I think no questions. How can I finish? Okay, thank you so much. Thank you for listening. If you have any questions, you can contact with me. I already uploaded I'm gonna upload my slide on Twitter. So yes, thank you so much.